Almost every enterprise suffered at least one coin miner incident in the past year. How many of you here have experience with malicious coin miners before this talk? Raise your hand. Anyone? That's cool. All right, I see some cool hands, so that's good. So basically, it's a problem. It's an issue. And when we started the research, our main goal was to analyze, understand these threats, so we can give some defensive tactics in order to prevent it. My name is Omri Moyal, and I'm the co-founder and head of research at Minerva Labs. My friend and colleague Thomas Roccia sadly couldn't make it. He's from McAfee Advanced Research Team, and together we did this coin miners are evasive research. So what we're going to speak about today, we're going to speak about the threat landscape and the rise of coin miners. We're going to deep dive into the evasive tactics employed by this threat. We're going to look at the gang territorial wars between competing coin miner threat actors, and we're going to suggest and recommend some defensive tactics because it's not a true security talk if you can't get some security out of it. And we're going to look at some predictions of what are the things we are expecting to see in the future from coin miners. So sit back and hopefully you will enjoy it. You probably heard about either legitimate coin miners, but there's also a lot of news recently in the past year and a half related to malicious coin mining. Just in the past month, we've seen malicious coin miner disguised as a flash update that has been spreading in a lot of organizations. We have seen reports about massive increase in Mac OS 6 coin miners. And a bit more recently, we've seen a new attack, again, exploiting Docker images to deploy coin miners. So basically, a threat actor would have uploaded a malicious image already with a coin miner inside, and then the victims would just go to the Docker store and download it, and that's it. A really good innovative supply chain attack to deploy coin miners. So basically, we want to understand how this threat works, what are the key features behind it, and how they keep evading our defenses. What are the evasive techniques they are using? So we'll explore that in this talk. So to better understand it, we first need to understand a few things. And one of the most important things is that what is the business model, and also what is the motive of attackers using coin miners? So basically, the way coin mining works is that you are using computer resources, CPU, GPU, and ASICs to mine cryptocurrency. Now, originally, it was intended to be used by legitimate people trying to make income from the feeds of mining, like a taxation in blockchain technology. But attackers have quickly understood that they can hijack victims' resources, servers, endpoints, routers, mobile phones, browsers, to make a profit from other people's resources. Also, mining solo on your hardware is almost no longer profitable, maybe if you got really big farms. But attackers don't need to pay electricity bills, they don't need to buy hardware. All they need to do is hijack a system. Basically, also, we have noticed that attackers, like legitimate miners, are using what it's called mining pools. Mining pools is like the commonest way for miners to share their resources to gain more profit, a more steady profit that will be divided by how much resource they donate to this network. That concept is called mining pools, public mining pools. Also, what we've discovered is almost, I don't want to say 100%, but around 99% of malicious crypto mining is based on Monero. Monero, also in a shortcut for as XMR, is a relatively newer coin than Bitcoin and Litecoin, etc. Monero has some really strong features that makes it almost perfect for attackers. So first of all, it has really strong anonymity based algorithms. So for example, if you compare it to Bitcoin, let's look at the Bitcoin wallet address. It's somewhat like the equivalent of your home address, your physical home address. Monero is wallet address is more of like your PO box or virtual PO box, where it's not so easy to track. Also, Bitcoin, it's like walking around the street with your wallet open, and everybody can see how much money you have. In Monero, it's much more harder to see each wallet and how much there is in there. So also, transactions are much more harder to monitor. In addition, Monero is also optimized to mine with CPU, where in Bitcoin and other GPU and ASICs is what you need. So for attackers, it's much more easy to get hold of CPU systems than other type of processors. In addition, Monero has a really strong community and a really strong and good open source free tools that both legitimate and attackers can utilize. And we'll see a few examples of it soon. Now, don't get it wrong. Monero is not a malicious technology. Monero is actually neutral, like money. Money can be used for good and can be used for bad. Same way as drug dealers are using money, malicious actors can use Monero. Now, a good thing, the community of Monero, the people behind it finally started to realize, but there is a problem here. Monero got a bit bad reputation. So they created what they called the malware response team. And the malware response team has a really good set of resources and team behind it to help any incidents of crypto mining, malicious crypto mining using Monero. So you can Google it up and check if you want. They're actually on IRC, but they have an email contact if you want. Now, how are these malicious coin miners actually infect our systems? How are they getting to the enterprises, to the computer machines? So first of all, from our research we've seen, a lot of them are pretty much similar to traditional malware, traditional infection vector tactics like spam, mail spam, malicious documents, exploit kits, Trojanized software. They are not much different than what of the typical malware you see, but they're also heavily relying on worm abilities. A bit similar to ransomware. In coin miners, you are subject to see much more frequent worm abilities. Now, why is that? Typical Trojan doesn't need to install on all of your organization computer. It just needs to get the right ones that have all the data. CoinMiner, pretty much similar to ransomware, make money per machine they are infecting. If ransomware is encrypting and then you pay each machine, in coin mining, each machine they infect, that's the CPU they get, and that's how they make more profit. So worm is really, really important factor here. In addition, unique to coin miners, they have the what we call the web mining or cryptojacking, and basically any machine that can run a JavaScript, for example, that has a browser or some way to browse URLs, are subject to be attacked by malicious JavaScript that are going to use that computer resources for mining. Vast majority behind it is a service called CoinHive. You might want to read about it, but basically a framework that anyone can use, take that JavaScript, put it in a website, in any malicious website, and utilize that for making profit. Now, you're asking yourself, what is the big deal behind coin mining? What is the damage? What can you actually do to my machines? Why should I care about it? So, I mean, it's not a ransomware. It's not going to encrypt my data. But what is it actually doing? So first of all, it's almost similar as a denial of service attack. If your machine is infected with a coin miner, most of them are not nice. They are using all the resources they can, and your machine will start run slow. If you ever encounter a data center, and trust me, it's not a pleasant sight, that has his entire servers infected with coin mining, one of the first obvious thing you will see, even before the denial of service, is the electricity bill. Electricity bill jumps really, really high in those data centers because the machines are working really, really hard. Another problem is a lot of people are using the cloud now. And in the cloud, you actually pay for what CPU you use. So if you got infected with a coin mine, that damage is really, really direct and right away. Now, the main focus of this talk is the evasiveness of coin miners. But let's first understand and define what an evasive tactic is. Basically, there's a really good definition here, but if you put it in a short sentence, evasive tactics, evasive techniques are the tools and methods that attackers use in order to evade security tools, defenses, monitoring, etc. They are broken to several categories like anti-sandboxing, the ability to evade sandboxing technology, anti-debugging, the ability to evade debuggers, etc. This is why attackers are actually calling them antis. If you look at any dark form or something, this is how they describe it. So it's pretty cool. Now, the way we constructed it is by case studies. We think case study is a really good way to show examples of the frequent evasive tactics that we've found in the wild. This is an example of a coin miner called WaterMiner. WaterMiner was discovered by our team at Minerva. It is a Trojanized GTA online game mode. Basically, the author of that cheat mode implemented a coin miner inside the mode and tricked all its users while using the mode to run and make profit from him in the background. WaterMiner was first payload. What they did is, soon as the mode was installed, it would have run a script that downloaded a secondary payload, which was the coin miner, and then that coin miner would have run in the background like a fake Oracle or Intel processes. So it was harder to detect. Now, I remember I mentioned that Monero has a really good sets of open source tool, and one of the most frequent used by attackers is a tool called XMRig. XMRig is basically a really efficient tool to mine and connect to public pools. So what the author here did, the way you run XMRig is by adding command line parameters to connect the tool to the public pools, give it the wallet address, the protocol you want to use, and the threads you want to run in. But that makes it really, really suspicious and really, really easy to detect by defenders. So the attacker took the code, changed it a bit, so those parameters would have been embedded inside the code before executing. Now, really, really clever thing that they did, and followed by a lot of coin miners as well. Let me ask you a question. If you think about it, the victims of WaterMiner are pretty super users. It's either kids or people who play computer games and cheat. They downloaded cheats and downloading modes. Now, what do you do? What a super user does when their machine is running slow? Any suggestions here? What do you do if your machine starts to run slow? You work with your laptop, it doesn't work, something gets stuck. Any suggestions? Cool. So basically, you either reboot, but if it stays, then you probably open something like a task manager or process explorer, or in Roccia, where this mode was operating, you open a program called Endvir. Now, what the author of WaterMiner did is, as soon as you open a task manager or Endvir, the mining process would have run to a halt, no longer taking a lot of CPU. And you probably would have blamed your Chrome or the game or any other software killed it, and then you shut down your task or monitoring tool, and it would have came back. So it's really, really smart and is deployed by a lot of coin miners. Another coin miner threat is called Evasive. Evasive has, other than being a coin miner, it has a really cool, unique features targeting cryptocurrency users, other than just being a coin miner. So first of all, it was heavily packed, so it wasn't that easy to analyze, but after you manage to unpack it, you can see some really interesting features. So first thing, they would hook your keyboard, and after hooking your keyboard, they have a few regex that whenever someone copy a wallet address of either a Bitcoin, Litecoin, XMR, and some other cryptocurrencies, they would have switched the copy wallet address to their own wallet address. And let's say, I give you an example. I got a friend, my mate loves Bitcoin, and he wanted me to send him like 20 Bitcoin because I lost in a bet. I copy his Bitcoin address and I paste it. I think I pasted his address, but I actually pasted the attacker address. Very, very few users will actually notice that, especially if you're not familiar with the address. So it's pretty clever to see. I believe it was successful. I don't have the numbers. Other things they did was looking at the registry of the machine, looking for wallet software like Bitcoin, QT, etc. And they would have grabbed the wallet and send it to the attacker. And they were not stopping with that. They were actually stealing cookies related to cryptocurrencies as well. So this factor was first using your machine to hijack and make some cryptocurrency, but also steal your wallets. So it's really cool. You can see here a few examples of the code of this attack. Now, mid last year, there was a very devastating attack, ransomware attack in the world. It was using a ransomware called WannaCry. WannaCry was a really vicious worm ransomware that was spread via the leaked NSA exploits, Eternal Blue, Double Pulsar, if you heard about them. But at the same time, WannaCry was running, there was another massive CoinMiner using the same exploits and almost the same worm capabilities called UIWIX. Hopefully I pronounced it right. How many people here about WannaCry before? Yeah. How many people heard about UIWIX before this talk? Yeah. The reason not so many people heard about it is because it was employing over 200 evasion tactics. It was basically putting everything in the categories we've seen into the code, copy and paste it, some of their own innovative. A lot of researchers that deployed honeypots to capture WannaCry actually captured UIWIX, but it was self-destructive, and basically you couldn't analyze it. They wouldn't find it, and they went on to WannaCry. Some of them even put a honeypot, received UIWIX, but then received WannaCry, so they didn't even bother with WIX till it was published. Our team analyzed that, and gave very good details on the threat. I think it was first discovered by Trend Micro, company from Japan, so good work. And if you want to go to the blog, there's a really good description of all those evasive tactics. It was using things like avoiding virtual machines, looking for debuggers and forensics tools, avoiding Eastern Europe countries, which might suggest where it's coming from, and even looking for Cuckoo Sandbox and trying to evade it. Now, another threat, I honestly don't know how to pronounce. I think it's Xiaoba. It's a threat from originally probably emerging from China. It was originally a ransomware that evolved or changed to be a CoinMiner. But it kept some of its ransomware features to become more successful CoinMiner. So first, a couple of evasions they used really frequent icons to lure some of the people to click on it. Really smart. They're using the same code from the ransomware, looking for HTML file and JavaScript files. And instead of encrypting them, they injected JavaScript mining code into them. So let's say it's a web browser, a web server, and you infect it, then any visitor of that web server will also be mining with the JavaScript miner for the attackers. They will also redirecting AV domains in the local host. Pretty an old trick, but it still works sadly. Disabling SafeBoot, the registry, deleting some specific ISO files. It was still a ransomware, and it was also infecting every portable executable in the system with the same miner. Wasn't that successful because that specific thing actually crashed most systems. So you can see here the local host. You can see the HTML infected with the JavaScript. You can also see the icon, etc. Cool. So other than being really, really evasive, there is also quite of a feature that we've looked at coin miners, and we discovered that they are very, very competitive. Anyone who's done instant response for a long time probably found a machine with like 5, 6 malware feasting from the same endpoint, all living together for like 3 years. Nobody cares. It's all good. We are all a nice, big, happy family here. But coin miners, really similar to ransomware, are very, very strict about gaining exclusivity in their victim machine. Why is that? Look at it, two coin miners running on the same machine. First, of course, they're gonna share the resources, so they're gonna generate less income, but also they're probably gonna crash the system. So some of them, and the more sophisticated ones, have developed a really cool features to kill their competitors. So ghost miner is another threat. We have first found it where we got an alert preventing a fileless attacks in Minerva, and we quickly went and investigated, and we found a complete fileless framework built out of PowerShell and some memory injections. It was using a couple of worm capabilities, like exploiting Oracle WebLogic attack, MS SQL, SMB. Recent versions also started to use Mimikatz. So it was really propagating in the network. You can see here a taskbar open and how many network activity it does trying to find more machines. And you can see here in the network capture, it was actually using XMRig, which we described earlier. Basically, Ghost Miner was really evasive, was using quite a cool part of PowerSploit. PowerSploit is a fileless framework, and they're using a command called invoke reflective PE injection. Originally it's reflective DLL injection, but it's a way to execute foreign code in a remote process without registering the DLL or the PE itself. So it's a way to bypass most antiviruses today, etc. So an example, the first generation of Ghost Miner was using a file on disk, and we found that after we found the Ghost Miner, we were able to track down in antivirus total to find some key features. It was used earlier, and you can see the first generation was heavily detected by the antivirus community, but the second generation was not detected at all, at least at the start. But other than being really evasive, Ghost Miner, the authors did an amazing research on their competitors. They analyzed them, and they created an amazing set of tools to kill competition. So what we did, we have reverse engineered and deobfuscated the code, making it a bit more safe, and we shared a script called Miner Killer. Miner Killer can be used by incident response team and defenders to actually go and hunt and kill coin miners in their network. If you do decide to use it, please use with caution. It's actually used to kill applications, but go ahead and look. Should be very educational. So here's an example of Ghost Miner in action. Basically, you can see here, there's an XMRig process running in the background. In the left side, we're going to execute the PowerShell. And as soon as we'll execute the PowerShell, it will basically use techniques used by Ghost Miner at the start, looking for specific names, and then it will kill the XMRig. It has also other features. It will look for scheduled tasks, services, network traffic, stuff like that. So it's pretty effective. All right. Another very, very competitive coin miner is Adicus. And again, probably I'm not pronouncing it right. But Adicus was a coin miner, started around April last year. But it then emerged big after the NSA exploit were released after WannaCry. But unlike UIWIX and WannaCry, it was using the exploits manually. The attack actually went machine by machine and trying to exploit them. The team, Thomas and the team at McAfee, have analyzed and compared samples before the exploits were released and after, and they found really interesting bit. And that bit is that the new samples have been using a batch file to patch the systems that they infected. So before running the CoinMiner, first thing they did, let's exploit the system, get a hold of it, and then let's patch it. Why would they patch it? They don't want anyone else to get into that system as well. So it's quite funny. I was thinking, what do I prefer? Ransomware or a CoinMiner? I don't know. I bet it's a CoinMiner. So those evasive tactics are not the only one you can see in coin miners, but the main features they use evasive techniques in coin miners is that they want to not be discovered. And usually how coin miners are discovered is by generating a lot of CPU overload. So one of the recent things we're starting to see, for example, a coin miner we called Nice Miner. It's not that nice, but it's nicer than others. It's using a single thread to run. So they're probably going to make less income or less coins at the start, but in the long term, they're going to be less detected. So they might make, longer run, they're going to make more money. Also, we've seen some really clever techniques to only monitor on specific working hours, like using the domain logon and working hours, and whenever those are over, they will start mining. And even more clever and more effective, I believe, is to monitor for user inactivity. So for example, they will hook the mouse functions, the keyboard functions, and screens related functions. And whenever there's a movement or stroking or changes in the screens, they will stop executing the coin miner. User goes to grab a coffee, go to lunch, go to sleep, go to over the weekend, they will run. So it's really, really effective. Related to web mining, we started to see some other clever techniques, like using a really, really small pixel in the tab of the browser. So basically, user don't see it and actually don't exit it. And also things like popping under taskbar and other places. So users won't be able to see those frames. Now, we took the most common evasive tactics of coin miners, and we put it was actually a really huge table at the start, but we decided to minimize it to the cases we showed here. But it's really, really obvious to see two features that are in most coin miners. The first of them is anti-monitoring, and the second is memory injection. Now, if my talk was right and I was a bit educative here, some of you, or maybe all of you, are already kind of understanding why these are the basic features or the most used evasive tactics in coin miners. Anti-monitoring, it's because you want to hide the fact that you are using a lot of CPU from system admins, for super users, or anyone who look for why their computers are running slow, like in the case of water miner. The other thing that they're using memory injection is because they can run their malicious coin mining inside a process, for example, like SVC host or others that are really prone to use a lot of CPU, so it wouldn't raise suspicions. A lot of logics in both human analysts, and some of the product is going basically like that. If it's using a lot of CPU and it's an unknown process, then it's probably a malware. If it's using a lot of CPU and it's a known process, then it's probably some really bad application. And a lot of attackers want to be like a bad application. Nobody deletes a bad application. So this is why they are using memory injections as well, process injections. Now, as I said, it's not a really educative talk if we didn't give some tools to mitigate the threat your own, or give some defensive tactics. So one of the first tactics we'll suggest is to use monitoring tools to look for high CPU. When I say monitoring tools, don't be confused with Task Manager and then tell your users once a day to open Task Manager and then read out the printout. I'm looking for things like in data centers to use things like OS query or a stack of Elastic to look for CPU activity. There are also some built-in tools in the operation system that are less prone to be manipulated by anti-monitoring tactics. I will share some on my Twitter in the next couple of hours after this talk. Here's a link to the miner killer we have released. Don't just use it as a script kiddie and run and hope that it will kill coin miners. Study it like we did. Study what Ghost Miner have researched and what they found is effective against miners. You're probably going to find some really cool insights out of it. If you do have your own additions, please feel free to do comments and pull requests. We'll be happy to add some. The good folks at McAfee and Thomas have shared a nice set of Yara rules to detect XMRig and other coin mining related threats. It's a pretty good list. It keeps frequently updating, so please use that. Also, we really recommend monitoring traffic using tools like Suricata and Snort and other, even more commercial tools. Coin miners can mostly be easily detected in the network, especially if they use mining pools. Mining pools traffic and protocols are pretty unique to them and also pretty standard. Which brings me to the last recommendation, but not least, there is a threat intel source, the best for coin miners, which is called Coin Blocker List. Coin Blocker List is maintained by Zerodot. There's a link here. And Coin Blocker List is really, really effective, and a lot of research constantly updating it, looking at domains and IPs related to coin miners. You can use it in many ways. Here's a quick demo as an example. What we did, we have took Coin Blocker List and used Little Snitch block list and joined them together in a Mac environment. And in here as an example, you can see on the top, it's a website infected with CoinHive. And you can see it using a lot of CPU. As soon as you enable Little Snitch to block any Coin Blocker List domains, you see the CPU drops because it doesn't connect to a CoinHive. If you are managing the firewall of your organization, this is going to be very, very effective. Vast majority of coin miners, at least today, they are moving a bit away from it, are still using mining pools, and those domains and IPs don't change that frequent. So threat intel, unlike most malware attack today, is still quite effective. They are moving from it. I'll speak about it in the prediction. Another thing that recently did, I wrote a really cool, easy search bar for Coin Blocker List on my website. So if you look at the domain and it's using a lot of CPU, you want to check if it's already in the Coin Blocker List. You can check it here. It's actually using an API. There's also an API for it. And this is going to be more sophisticated soon. You can actually add domains to Coin Blocker Lists. You can take out domains if you think it's a false positive, etc. So, and we're going to automate that as well. So stay tuned. Now, I'm not a big gambler, but I think we can already see some future trends in coin miners. It's a new threat, but it's moving rapidly fast. So we are actually predicting it's going to increase even more. When we first researched it, it wasn't that big. Now we've seen major shift from ransomware actors to coin miners. We've seen threat actors jumping on that wagon. Even huge Boit miners like Necrus and old Zeus are now deploying add-ons to whenever they decide to run coin miners. So it's going to be even bigger. Another thing of it being big, we're already starting to see, but it's not that big, but it's going to be much more frequent soon, I believe, is they're going to attack more different unattended devices like routers, IoT, light bulbs, air conditioning, basically everything that connects to the internet. And the reason for it, it's really hard to monitor those devices. And also, they have a lot of vulnerabilities. So they can get in there. And today, what do you do with a vulnerable or hijacked IoT device? If it's an organization, maybe you can use it as a pivot point to get into the organization. Maybe send spam, not easy. If you run CoinMiner, this is a really good use case for those kind of devices, even cars. We are going to see, and we started to see the really small seeds of it, of instead of using mining pools, we are starting to see malicious mining pools that were built in the sole intention to provide a secure hidden home for malicious crypto miners. So instead of they use the public pools, which use similar domains, IPs, they're actually going to use the things like proxy and domain generation algorithms and going to change the IPs, etc., to make it much more harder to detect. And it's a prediction, but probably believe we're going to see that. And we also believe they're going to be re-innovating some of their evasive tactics, maybe also because they see this stock and they need to improve. All right, so just a quick recap of what we discussed in this talk. We have looked at the landscape, the rise of coin miners, what are the basic features of it, things like XMR and mining pools. We have deep dive into some of the more frequent evasive tactics and tools. We have looked at some of the competition behind the coin miners and how they actually operate. We offered hopefully some good and defensive tactics that you might use. And we have explored some future trends and prediction that hopefully will never go, but if they do, we might say we're right, or maybe they go using something else. Cool. So, arigato, konai master. Thank you.